Hello friends, welcome back to your UPSC. So today we'll start with our new topic of geomorphology, that is physical condition of Earth's interior. So let's get started. So in physical condition of Earth's interior, I hope you are familiar with this diagram. This diagram shows path followed by seismic wave through the Earth's interior. Okay, so this is the path followed by P and S wave when it is passed through the Earth's interior. Okay, so we have studied it in detail in previous lectures. So we will jump to another thing. So now with this diagram, the scientist came to the conclusion that there are three distinct zones. Okay, so what they actually did was in this experiment, they saw that the velocity of seismic waves change with the change in density of rock. Okay, so the waves always change its velocity, like because it is changing its velocity, it is following curved path because the area from which it is passing is not homogeneous. Okay, so obviously as the density is varying, so the velocity of seismic waves are also varying. Okay, so on the basis of the velocity of seismic waves, they are divided into three sets. Okay, so first set is of maximum velocity. We call it P and S wave, simple P and S wave. Then minimum velocity is PG and SG waves. Okay, and the medium velocity, that is between maximum velocity and minimum velocity, is P star and S star waves. So on the basis of wave velocity, it is proved that there are three major changes at three places. Okay, there are major changes at three places inside the earth. Though this, see, though the waves were following, means they were not straight, but there was a continuity. Okay, but at three places their direction suddenly or abruptly changed. Okay, like we can see here. Firstly, the wave is moving like this. As soon as it enter this area, okay, it changes its direction and then follows this path, and then as soon as it comes out, it again changes its direction and follows this path. So so it was safely inferred that there are three distinct zones or layers of varying density inside the earth below the thin layer of sedimentary layer. Okay, so these three layers were called as upper layer, intermediate layer, and lower layer. So in upper layer, that is below sedimentary layer, its density was considered as 2.7, and it was composed of graphite rock, uh, and the waves were PG and SG waves. Their velocity is 5.4 km per second and 3.3 km per second respectively. In intermediate layer, there were P star and S star waves. Okay, so P star's velocity was 6 to 7 km per second and S star's was 3 to 4 km per second. The density was calculated to be 3 and the composition was considered to be basalt. Now, the lower layer, here the maximum velocity waves were passed and the velocity of waves were 7.8 km per second for P waves and 4.5 km per second for S wave. So it was at the depth of 2,900 kilometers, and they thought that the material which this layer was composed of is either peridotite or dunite. Okay, so that was the interior of Earth according to seismic wave theory. Now, according to Swiss, he said that apart from the thin layer of the Earth, there are three different zones of different matters below thin sedimentary layer. Okay, so here is the diagram. There are three layers, one, two, and three layer below this sedimentary layer. Okay, so he called the first, that is sedimentary layer, as the upper layer. He said that it was composed of crystalline rock, mainly of silicate matter. Okay, and the minerals dominant here are feldspar and mica. Okay, the upper layer of this, the upper part of this layer is composed of light silicate matter. So he divided this upper layer into two parts. Okay, so this upper part was formed of light silicate matter, and the lower part was composed of heavy silicate matter. Okay, so that was the upper layer. Now, the second layer is Sial. Sial layer, it is dominated by silica and aluminium. Okay, so Sial, the word is formed by Si of silica and Al of aluminium. Okay, so these two combine to form Sial. Okay, its density is 2.9 and the thickness is about 50 to 300 kilometers. Okay, it forms continents. So the Sial layer forms continents, and it is dominated by acidic materials like potassium, sodium, aluminium. Okay, potassium silicate, sodium silicate, and aluminium silicate are abundantly found here. Now, next layer is Sima. Sima, as the name suggests, it is composed of silica and magnesium. Okay, and the density is 2.9 to 4.7 gram per centimeter cube. Thickness of this layer is 1000 to 2000 kilometers, and it is composed of basalt, which is abundant in basic material like silicate of magnesium, calcium, and iron. Okay, and now the last layer, that is Nephi. It is composed of nickel and ferrum. Ferrum is iron, ferrous. Okay, and its density is about 11 gram per centimeter cube. That is the highest density among all these layers, and it's because this layer is Nephi. Okay, this is Nephi, so we will consider its diameter. So its diameter is 6880 kilometers. Okay, so this was whole structure and layering of the earth according to Swiss. Now we will come to the recent view. What is the recent view of our earth's physical condition? Okay, physical interior. So now in this diagram we will study the recent view of what our earth is composed of, or the physical interior of the earth. Okay, so this is the uppermost layer, that is sedimentary layer, uppermost sedimentary layer of earth's surface. Okay, below this we have crust. This crust is about 2.9 or 3 gram per centimeter cube in density, and below this crust we have mantle. Okay, from 30 kilometers to 2,900 kilometers, we have our mantle. And then from 2,900 kilometers to the end, that is 6,371 kilometers, we have our core. So, first we'll start with crust. Crust, as we all know, is basically composed of Cl, okay, that is silica and aluminium. It is having the density of 2.9 gram per centimeter cube. And then we have our upper mantle and then lower mantle. So the mantle, its total average density of the mantle is 4.5 gram per centimeter cube. Okay. So the whole density of mantle is 4.5 gram per centimeter cube. But when we divide it into subcategories, so the upper mantle is divided into two parts. That is, first upper part of upper mantle is having the density of 3.3 gram per centimeter cube, and the lower part is having the density of 4.5 gram per centimeter cube. Then we have lower mantle. Lower mantle is having the density of 5.5 gram per centimeter cube, and this is the intermediate layer at 700 kilometers, and the first intermediate layer was at 200 kilometers. Now at 30 kilometers we have our moho discontinuity, that is our first discontinuity. This discontinuity separates crust from the mantle. So how this discontinuity came into existence? So what happened was, scientists, they actually passed the seismic waves. So here, till the lower crust, the speed of the seismic waves, sorry, the velocity of the seismic waves was 6.9 kilometers per hour. But abruptly or suddenly, the see, this is the upper crust. Okay, this is the lower crust. So when the waves were passing from crust, their speed was 6.9 kilometer per second. Okay, but as soon as they passed this layer, their speed abruptly or suddenly changed to 7.9 to 8.1 kilometer per second. Okay, so this was a huge change. So this part was considered as a discontinuity. Okay, so this trend of seismic waves, it denoted discontinuity, and this discontinuity was known as moho discontinuity. Moho discontinuity. Okay, again out of focus. Okay, so then we come to our outer core and inner core. So this is our core from 2,900 kilometers to 6,371 kilometers. This is our core. And this is separated from mantle. Core is separated from mantle via Gutenberg's discontinuity. Okay. This discontinuity is commonly known as Gutenberg's discontinuity. So here, the speed is not the major factor, but the density. So we have seen that the lower mantle was having the density of 5.5 gram per centimeter cube. But as soon as we reached here, the density suddenly changed or suddenly jumped to from 5.5 gram per centimeter cube to 10 gram per centimeter cube. Okay, so this discontinuity, that is at 2,900 kilometers, this was considered as discontinuity and was named as Gutenberg's discontinuity. Now, our core is also divided into two parts, and there is an intermediate layer at 5,150 kilometers. So above this, the density of the outer core from 2,900 kilometers to 5,150 kilometers, the density is about 12.3 gram per centimeter cube, and the density of our inner core is 13.6 gram per centimeter cube. Okay, so the inner core ranges from 5,150 kilometers to 6,371 kilometers, and the density at the intermediate layer is 13.3 gram per centimeter cube. So this is actually the whole physical interior of Earth. Okay, this is the physical condition. And this crust, what other names are given? See, this crust, that is the outer layer, sorry, this outer layer is known as lithosphere. Okay, and from 0 to 200 kilometers or 250 kilometers, basically 250 kilometers is our asthenosphere, and from 250 to 2900 kilometer is our mesosphere. Okay, so this is another division of Earth, that is lithosphere, asthenosphere, and mesosphere. So another, and there is one more division of Earth, that is lithosphere. Lithosphere, it is from 0 to 100 kilometers. Then from 100 to 2000 and 2780 kilometers is pyrosphere, and from 2800 kilometers to 6000 and 6371 kilometers we have barysphere. This is according to Van der Garchet. Okay, this division is according to Van der Garchet. So that was the recent view of the physical, or sorry, the interior of Earth. So that was all for today, guys. I hope you enjoyed the lecture. So let's meet in our next class. Till then, take care and have a nice day.